Okay, I hope my slide is visible. Okay, so we are moving now towards our fourth chapter for this module, okay, which is on IoT access technology. Last time we finished our discussion on a IoT platform. Now we are going to discuss about the communication technology. Access technologies means communication technologies. So from the very beginning, let me mention to you, there are two types of access technologies or communication technologies that are relevant for a IoT. One that we will call short distance communication and one that we'll call long distance communication. So short distance communication is required for sensors to communicate with some gateway, sensors communicating with sensors. And long distance communication is required when eventually those data needs to be transmitted to long distances, to base station or to the internet eventually. Okay, so we'll discuss both types of technologies. So this chapter is over 2 weeks anyway. So and I forgot to mention to you next week after you that we will have our class test on Thursday, but on Monday there is a innovation week which is starting at the university. So next Monday we will not have our normal online lecture. Okay, so we will not have online lecture next Monday, but we will have the class test on Thursday. Okay, let me continue with our chapter 4, which is IoT access technologies or IoT communication technologies. So what we are talking here, we're talking about IoT connectivity. So at the end of the day, the data that we are capturing, the sensors are capturing data, it needs to be transmitted among the sensors and to the cloud eventually. Excuse me. So numerous connectivity standards deployed in the market. So we don't have one communication technology for IoT. You have many spread over multiple frequency band. So it's very important when we talk about communication technology transmission. So let me put a question to the class. Anyone with an answer can reply to me. Put your mic on and you reply. So tell me a few communication technologies that you are aware of for data transmission in general. And we will see whether these are relevant for IoT or it is not relevant for IoT. Okay, tell me, what are those communication technologies that you use very often?
Wi-Fi.
Okay, one of my friends saying Wi-Fi. It is an option. It is an option. The normal Wi-Fi that we use is not appropriate for IoT. As we will proceed in the lecture, you will see why. Okay, we cannot use Wi-Fi for IoT. Yes, Wi-Fi is a popular communication technology. It's, at the same time, it is wireless. So it could have been a serious candidate for our IoT, but it is not. Maybe we can already do some reflection with the class. So one of your friends mentioned about Wi-Fi. Let me go to the attendance sheet. Jason Evans, Henri, are you around?
Yes.
Okay, tell me why we are saying that Wi-Fi is not appropriate for IoT. Any guess?
I think because of energy.
Yeah, Wi-Fi do consume lots of energy. That's true. That's a correct answer. So indeed, Wi-Fi consume lots of energies, and we know that our sensors, they are very constrained in terms of energy. So it is not appropriate. Okay, let's have other communication technologies and see whether they are appropriate for IoT or not. So we have already discussed about Wi-Fi. Rojua, Alia. Yes.
Yes.
So what do you think? What other communication technology that you are aware of?
Bluetooth.
Bluetooth. Okay. Let's have another one. Bluetooth. We have let's have another one explaining whether Bluetooth is a serious candidate for IoT or not. If not, why? So yes, let's have Davis and Pemal.
Yes.
Bluetooth. What about for IoT?
No, because the devices have to be in a closer range?
Okay, so this is a reasoning, yes, because Bluetooth works in very close range. So if you want to transmit further, this will not work. Whether Bluetooth, however, as opposed to Wi-Fi, Bluetooth, we do consider Bluetooth for IoT, but obviously we do have issues with our normal Bluetooth. We won't be able to use a normal Bluetooth for sensors for IoT. But however, you will see as we proceed in this chapter, there is a special version of Bluetooth. This is called BLE, okay, which has been physically designed. So the new version of Bluetooth itself, which fits the IoT world, which fits sensors and everything. And we are going to discuss in detail about it. So we have seen Wi-Fi, we have seen Bluetooth. I think let's proceed. So Wi-Fi is in the range of, let me see if we can have Jumak Divya. Wi-Fi, what is your opinion about Wi-Fi? What is the distance normal Wi-Fi? For normal Wi-Fi, approximate distance it can cover? Yeah, Jumak Divya. Oh, you are on? You're saying no, this is not 1 kilometer. Normal Wi-Fi will not go that far. I've seen your answer on chat. So your friend is saying for Wi-Fi can go up to 1 kilometer. Anyone can give me, let's try Iot Joseph. Iot Joseph. I'm asking about the distance, normal distance for Wi-Fi, approximate. It may not be exact, but approximate. What do you think?
50 meters.
How much you said? 50? 50. Okay. Normally, yes, we can accept this one. Slightly more though. Okay, slightly more. We can go up to 75 if we have a very good Wi-Fi connection. I think so. Yes, it is within this range. It cannot go more than 100 meters or whatever. So it's good to know the distance is very important. Okay, so Wi-Fi. So two things we need to bear in mind when we discuss about communication technology. What is the distance it can travel, and about its energy consumption. This is very important. So we have seen Wi-Fi consume quite some amount of energy, which makes it not usable for IoT. And the distance we have seen, your friend saying 50 meters, 60 meters, it can go up to that. Okay. So let's talk about Bluetooth. Bluetooth, what kind of distance are we talking? Let's have someone, Bagalu. For Bluetooth, what kind of distance are we talking for Bluetooth?
It may go up to 100. No, Bluetooth range you're talking about.
Bluetooth. What do you think?
10 meters?
How much?
10 meters.
Around 10 meters. Okay, that's right. So it's quite short, a short distance. So yes, it cannot go too far. Okay. So this is in terms of distance. Now, see, for those short distance communication, we can be contemplating Bluetooth or whatever. We are going to see what are those technologies, but then we require long distance communication as well, very far. So what kind of technologies do you think do we talk when we in terms of IoT for IoT? Let's have for example Vikesh, Idana, Vikesh.
Yes.
We're talking about long distance now. So we've seen Wi-Fi is around 50, 60 meters. Bluetooth is only 10 meters. We're talking about long distance communication. Do you know any technology, any long distance communication technology?
Local area networks.
No, local area network, Wi-Fi. Wi-Fi is an example of a wireless local area network. Local is shorter distance. It's not long distance. If we talk about long distance, it is wide area network, WAN, not LAN. It should be WAN, wide area network. So which wide area network technology you are aware of? Any guess?
Microwaves.
Microwave is a signal, but which technology? Let's have Keshav, Kalichan can help out.
Radio frequencies.
RF, again, you're talking to me about what I'm talking, which technology itself, which a technology that uses RF or uses microwave that we commonly use for long distance communication.
Satellite.
No, again, you're talking about, let's have Edu Wasima. Yes, Edu Wasima. We're talking about long distance communication. Any technology, RF and microwave, they are used, but these are signals. I'm talking about which product, which technology. Just like Wi-Fi is a particular, even Wi-Fi use RF, but we don't say RF, we say Wi-Fi. So like this, I'm asking for a particular technology. Okay, Ethernet, the issue, yes, Ethernet is long distance, but Ethernet, it is wired. It is wired, and IoT, obviously, we will not be considering the wired. Okay, Kroshan is saying LoRaWAN. Okay, LoRaWAN is specifically used for long distance. But anyway, LoRa, let's say you are not aware about LoRa. For example, what you use in your mobile phone for long distance communication, for you to make a call, which technology are we using? Cellular, we use GSM, we use 4G. So all these are long distance technologies. All these are based mainly on RF and everything, but the technology is GSM, 4G. These are the long distance communication that we talk. LoRa, I will come back to it because this is basically for IoT. Okay, so let's get back to our lecture. So you see here we have done some brainstorming on different communication technologies that we have, and whether they are appropriate, or for example, whether GSM will be appropriate for IoT directly. This we are going to see in this chapter. So after completion of this chapter, you should become competent in knowing like what communication technology will be more appropriate for which situation in IoT, and why some technologies are not appropriate for IoT, and you will be assessed on this competence as well in your exam. Okay, so let's get started. So numerous connectivity standards deployed in the market. So we have already seen many of them: Bluetooth, Wi-Fi. Some of you said we say GSM, we said 4G. All these are communication technologies, but whether they are appropriate, we need to see, spread over multiple frequency bands. So now something I should already mention here, because we are going to use this a lot. When we talk about communication technology, with any communication anyway, for where you have data transfer, it sends a signal on a specific frequency. We call it the spectrum. Okay, the spectrum. So anyone can in the class can tell me, since you use Wi-Fi a lot, Wi-Fi operate in which frequency of the spectrum? Frequency spectrum. Which frequency? Anyone? Wi-Fi, which frequency? Chaman, Firdaus? What do you think? Which frequency?
2.4.
Yeah, 2.4 gigahertz. We say that Wi-Fi operate at 2.4 gigahertz. Yes. So this is the frequency. And what is a frequency of a signal? Is the number of oscillation, the number of pattern it makes in per unit time, in 1 second, for example. This gives you the frequency of the signal. So you have technologies that operate in higher frequency. For example, Wi-Fi 2.4 gigahertz. We can say it is higher. It's quite a high frequency. Now you have technologies that use lower a lower frequency. And by definition, I'm not teaching the wireless. I normally I teach this in wireless module. I think Mr. Malu is teaching this module now. Normally I explain, for example, the relationship between the signal and the frequency and the distance it can travel. So higher frequencies, they cover shorter distances because they have lots of repetition in one second, so they cover shorter distances. Lower frequencies, they cover longer distance because their wavelength, that is, they cover long distance in one cycle. So the frequency matter. Let's continue. So choosing the right, why we are studying this chapter is because of this. Choosing the right wireless connectivity technology for an IoT application can be quite challenging, and this is why we have one complete chapter on this for our module here, because you will be exposed to many technologies, so you need to know which one to use and when. Okay, so you can see on this slides here, there are different possibilities. You have a free group. So you have, for example, Ethernet. One of you mentioned Ethernet, but Ethernet is wired, not so appropriate for IoT. One of you mentioned earlier Wi-Fi. Wi-Fi is IEEE 802.11. It's a code name for Wi-Fi. Okay, Wi-Fi is being considered for IoT now, not our common Wi-Fi that we use, but another version of Wi-Fi. Okay. So, and then you have the group 15. Group 3 is Ethernet. Group 11, 802.11 is Wi-Fi. But what is mostly used for IoT is IEEE 802.15. You see here, 15, which is mainly for wireless PAN. Bluetooth fall under this. Bluetooth is IEEE 802.11.50 instead, not 11, but IEEE 802.15.1. This is Bluetooth, and it is anything that has 802.15 point something is a PAN technology. It's a wireless PAN technology. Like you can see here, IEEE 802.15.1 is Bluetooth. Okay, IEEE 802.15.3 is what is called high rate PAN, and IEEE 802.15.4 is low rate PAN. Okay, high rate, low rate. That is. We don't consider high rate for IoT. It's more IEEE 802.15.4. So you will see this a lot for IoT, this version. Not Wi-Fi, not IEEE 802.50.11, but instead IEEE 802.15.4. This will be used a lot for IoT. Okay, and the good thing about IEEE 802.15.4. What do you think? Why it is a good candidate for IoT? Anyone in the class? IEEE 802.15.4. I'm saying that it is low rate, so this doesn't seem to be an advantage. What is the advantage of using this one in IoT? Most IoT will use this one. Yeah.
Lower power consumption, maybe.
Yeah, it's all about power, right? You are right. Okay, so it has lower power consumption. Okay, the 15.4 has a low power consumption, and if we can try to look for a disadvantage apart from low rate is not a disadvantage as such, because anyway in IoT we don't transmit large volume of data. We transmit very small amount of data, but regularly. So what can be a disadvantage of IEEE 802.15.4 for IoT? Anyone in the class? A disadvantage apart from low rate. I will explain. Yes, try. The issue with 15.4 is its distance. It is PAN, meaning if you want to transmit data further, you won't be able to use this one for longer distance. This one is not appropriate because it is PAN, your personal area network. Okay, it's wireless personal area network. So all these fall under 15. That is Bluetooth 15.1, .4. Yeah, .4. You will see there are so many technologies that have used IEEE 802.15.4. ZigBee is one of them. 6 low wireless PAN, Thread, Entity. So all these are technologies that are used that have used this standard, IEEE 802.15.4. Okay, and it is quite popular for IoT. So So you need to recall this very well. Wi-Fi is IEEE 800.11. We don't use this one as such. We use this one a lot more for IoT, that is IEEE 800.15.4. Okay, so let's proceed. Okay, you see here in terms of communication technologies and IoT architecture, in terms of the communication. At the physical layer, you see what after you we use a lot. We use IEEE 800.15.4, or we can use Bluetooth, but not our normal Bluetooth, another Bluetooth that is called BLE, Bluetooth Low Energy. Otherwise, Wi-Fi is considered near field communication 3GPP. Something here, if we have time, we will reach there today. 6 low wireless span. It's in between. What is its role? Why it is important for IoT? We're going to discuss about this. Otherwise, ZigBee you see here. Okay. In order to connect to the internet, eventually we need our TCP IP. The application layer, next semester we are going to discuss about MQTT, COAP. This is other application layer for data exchange. But here, right today we are going to discuss mainly about these communication technologies that is relevant for IoT. Okay, so wireless connectivity for IoT, what are those technologies that are most relevant? Okay, Bluetooth is one, but not normal Bluetooth, but BLE, Bluetooth Low Energy. The word itself is very explicit, low energy, not normal Bluetooth, but low energy Bluetooth. Something called Z-Wave, 6 low wireless span after you. It's very important for IoT. Now there are technologies that falls under sub 1 gigahertz RF. Okay, I will explain what is this sub 1 gigahertz RF, what it is used for, why it is important for IoT. Then one of your friends mentioned about LoRaWAN. This is a very important technology for IoT for long distance. SigFox is another one, or narrowband IoT. So all these communication technologies we are going to discuss in this chapter. So you need to know when to use which one of this. This is very important, and you will be accessed on this. Okay, so you can see on this diagram, for short range down here, we use ZigBee, Bluetooth, even we can consider Wi-Fi. This is why I have done this exercise earlier, which technology short range, long range. You see here, for short range, you will most probably go for this. For long range, these are technologies that we are going to explore. But both needs to be low power. See, LP stands for low power wireless technologies. Here is short range, but they needs to be low power. Then this LTE, LTE-M, this is again for long distance, but for example, you use a GSM, 4G and everything. Now a LTE stands for anyone? LTE? Anyone in the class? LTE? Long-term evolution. LTE stands for long-term evolution. Okay, actually 4G is LTE, and we are moving towards 5G. So whatever we are using on our mobile phone and everything, we want it to be used even for sensors. We are not there yet, but this is why there is LTE. Okay, you can see here evolving IoT communication technologies. It depends, all these to show to you there are different application areas. There are very short distance, for example, when we have wireless implantable medical devices, sensors in our body. So these will be very short distance. In a city, this side here, car transmitting to car transmitting to buildings, whatever. This is a vehicular networks. Okay, so you can have for health devices or whatever. So you can see a number of technologies: BLE, NFC, near field communication, LoRa, LoRaWAN, Wi-Fi, cellular. All these are possibilities. Okay, let's take one by one now. Let's take a BLE. Okay, Bluetooth. Bluetooth is a serious candidate because Bluetooth is very popular, used already in many devices. This is why Bluetooth was explored even for IoT, for our sensors. It says here, but not any kind of Bluetooth. We are talking about BLE here. Is a wireless PAN. Okay, W is for wireless PAN, personal area network technology, designed marketed by Bluetooth. So aim at novel application. For example, in healthcare, fitness, security, home entertainment, and everything. So compared to classic Bluetooth, this one is intended to provide considerable reduced power consumption. You see what we have done here. We have reduced the power consumption of the Bluetooth a lot in order to get this Bluetooth low energy, so as it is more relevant for IoT. Okay, so it was predicted that by 2018, more than 90% of Bluetooth-enabled smartphone will support BLE. You can check it whether the current mobile phone that we are getting, we are already using BLE. Okay, yes, and BLE operates at 2.4 gigahertz, just like for Wi-Fi. Bluetooth operate in the same frequency. Okay, normally in normal Bluetooth you have 79 1 megahertz channel. This is the bandwidth, how we break the this bandwidth, that is this range of frequency that we have here, how we break it for data transmission. Normally, borrowing from the original Bluetooth specification, the Bluetooth defines several profiles. Yeah, normally in the wireless course, you will be exposed to different profiles for Bluetooth. Profiles means, for example, when you use Bluetooth for your earphone, for example, this is one profile. You use Bluetooth for transmission of a file or whatever. This is another profile. So majority of current low energy application profile is based on something called GATT, that is generic attribute profile in Bluetooth, and this is what our sensors is supposed to be using. You see a comparison here between classic Bluetooth, here is classic Bluetooth, and the new Bluetooth that I am talking. You will notice something, for example, application throughput. Here we were able to go up to 2 megabit per second, and here it is very low. Obviously, the data rate is very low, but this allows me to reduce the power consumption. Okay, so BLE is designed for sending small chunk, that is small amount of data with low overhead, very low power. This is what is called the protocol stack for BLE. Okay, I won't go into the details of all these protocol. Okay, in the wireless course, you are going to discuss about each of those layers. Yeah, so this was Bluetooth. So Bluetooth is a serious candidate for sensors, but not the normal Bluetooth, but BLE. Okay, and Bluetooth have been customized to make it low power. Now, second technology. So and also we should mention that Bluetooth is for short distance communication. Okay, another short distance communication is Z-Wave. Z-Wave is a quite popular technology in the IoT domain. Excuse me. So it is a wireless communication protocol used primarily for home automation. You see, in homes, it is a mesh network. Okay, mesh. I hope you understand what is a mesh network. Each node is communicating with every node. So using low energy radio waves to communicate from appliances to appliances, allowing wireless control. So such as in lighting for security systems, mainly using home systems, swimming pool, garage door opener. Actually, you are already using Z-Wave. Maybe you are not aware it is Z-Wave. It's quite popular in all those systems, in all the remote control systems and everything. And this is considered to be appropriate for IoT. So it provides interoperability between home control systems. It uses lower frequency. If we have checked, you see here, 800 to 900 megahertz. So this is lower than Wi-Fi, because Wi-Fi is gigahertz. Here we're talking about megahertz. Okay, so and it is growing a lot. So Z-Wave is designed to provide reliable, low latency. That is, very quickly you're able to transmit small amount of data, and the data rate is 100 kilobit per second. Not in terms of not even megabit, but kilobit. That is, the rate is quite low, but it doesn't matter because we don't have large volume of data to transmit in IoT system. And in terms of its distance, it's good to know we are talking in terms of 30 meters, so short distance communication, but it is enough to give coverage for most residential houses in your home or whatever. It is very appropriate. Okay, so we have seen Bluetooth, we have seen Z-Wave. Let's move on. And Bluetooth and Z-Wave, they were short distance communication. Let's move on to another technology that is called 6-low wireless PAN. Okay, it is a PAN technology, so we are still talking about short distance. But this technology is one of the most important technology when it comes to IoT, and you need to be listening carefully here. most probably you will be accessed on this one, because this is a very important technology for IoT. Why it is so important? Let me go back to back to this slide. Okay, what I've told you, most IoT are based on IEEE 800.15.4, right? So IEEE 800.15.4, with this technology, you cannot normally communicate with the internet. To be able to communicate with the internet, which protocol do we use? Anyone in the class? This one you should be aware. I think I've asked this question in the past as well. Which protocol do we use to communicate over the internet? So it's Ritu Ramjus. Ritu Ramjus. If you don't have a mic, you can use your chat. Ritu?
Yes.
Yeah, which technology we use to communicate over the internet? Which protocol?
The TCP?
Yeah, this TCP IP. Okay, TCP IP. So you need to be IP enabled in order for you to be able to communicate over the internet. This is very important here. And when you are using, for example, IEEE 802.3 Ethernet, it is IP based. Okay, and even when you're using your Wi-Fi, it is IP based. Okay, through Wi-Fi. Okay, Wi-Fi is a communication technology. This is why we say let's put Wi-Fi on in order to. Or people tend to think that Wi-Fi by de facto Wi-Fi allow you connection to the internet. If you have only Wi-Fi, can you? I set up an access point with Wi-Fi. I connect to the access point using Wi-Fi. Can I get access to the internet?
No.
No, you can't get access to the internet. If your access point is not connected to a router, which is eventually connected to the internet, you will never, even if you see Wi-Fi on, you don't get access to the internet. Wi-Fi doesn't allow you direct access to the internet. Wi-Fi is a local network among your devices. But however, Wi-Fi is IP enabled, so you can transmit and receive data packets. This is why on your mobile phone, when you put Wi-Fi on, you can view web pages and everything, because Wi-Fi is allowing you connection to the internet eventually. However, so this is very important here. However, when you're using IEEE 802.15.4, any technology, even have you heard, for example, connecting to the internet through Bluetooth? Anyone? Anyone? Can we connect to the internet using Bluetooth? No, we can't. Bluetooth is a different technology. It is not IP enabled. Okay, just like this, even your IEEE 802.15.4, all those technologies like ZigBee, Z-Waves, and everything, they are not IP enabled, meaning that the packet that they do use packet as well, but not same as TCP IP packet. So we have a big problem here. What is the problem? Anyone? Let me check. Based on the explanation that I have just given, Muzamil Jawahir. So what is the problem? We are saying that IEEE 802.15.4 is not IP enabled. It cannot connect to the internet. So what is the problem for IoT? What is the meaning of IoT? Muzamil Jawahir?
So IoT means Internet of Things. So the problem is,
yeah, and
the problem is that we cannot connect to the internet and we could not transmit the data to the cloud.
Exactly. So exactly, this is the big issue here. The big issue here is that I'm using IEEE 802.15.4 for my sensors, but those sensors they are not IP enabled, so they cannot connect to the internet eventually. how my data will go on the cloud. So I have a big problem because I want my data to be accessible from anywhere on my mobile apps that I take it from the cloud. So we have a big issue here. Most of our IoT system, they use IEEE 802.15.4, but this doesn't allow me to transmit the data to the cloud eventually because it is not TCP IP enabled. This is where, this is the rationale here, this is where 6-low wireless PAN, this is where this technology becomes very important. Okay, what is